Hello, my name is Stefan Achtznet and I'm the CIO of EOx, a geospatial software engineering and consulting company located in Austria. In this video, I will demonstrate the capabilities of EOxHub, an Earth observation, exploitation and large-scale processing platform used for the deployment and execution of processing jobs defined as OGC EO application packages. These capabilities have been facilitated during the OGC Earth Observations Applications pilot through the work of different people. People from the West University of Timisoara, who evolved their existing EWPS processing solution to support application descriptions via CWL, who implemented a data staging mechanism to shift data between the processor and the underlying platform, and who provided a Kubernetes implementation natively bridging processing jobs with Kubernetes job functionality. With the work of people from EOx, who opened their EOxHub exploitation platform for this Kubernetes native integration, who connected all the dots for above-mentioned data staging mechanism, and who rewrote a real-world application to a working example of a small Agri app repackaged as EO application package. And with the work of people from DLR, Synergize, and from TerraSigna, who contributed further application packages for testing and evolution. Please find more detailed information on technical aspects in the accompanying engineering report provided by the team. This video will highlight aspects and concerns handled by EOxHub as underlying platform when used in conjunction with EO application packages. On the one hand, we have the domain-specific concerns. Here we can put discovery and retrieval of EO data, functionality which should be externalized from the application and put up declaratively in the application package. EO platforms are specifically built for this use case. They are physically located close to EO data sources in the cloud or on a DIAS, and they also have dedicated data connectors bundled and offer specific managed services for EO data access. The EOxHub platform supports direct data access to huge object storage archives like on AWS or on the Mundi DIAS, and offers various managed services like the EDC Sentinel service for global EO raster data access. We can also list the registration of processing results here. All generated artifacts should be properly described by the application creator, so the platform can leverage this information and make it discoverable for subsequent processing. EOxHub offers the so-called EDC Sentinel Hub Bring Your Own Data functionality, a specific API for the registration of additional EO raster data. On the other hand, we have the cross-cutting concerns, with multi-tenancy being one of them. Only after authentication, a dedicated workspace can be attached to a user, with his own customized application packages, defining his processes, his configuration settings, and also including his previous processing artifacts, with resource quotas being another one. Get processes with the necessary resources as stated in the application package running. This can be a stated demand for GPU support to boost numerical computations, or the need of node-attached block storage for high throughput workloads. And also get all listed resource limits passed from the application package to the execution runtime, to not exhaust the system. Finally, operational metrics, allowing the end user to understand the runtime behavior of his processes, and the platform provider to do proper reporting and billing, with the application package defining which information should be tracked. Let's get concrete and see what EOxHub can bring to the table when running EO application packages. We will take processes from DLR's timescan processing framework as example. A single-step process, data to time series, packaged as CWL command line tool. Then a multi-step process, a workflow, with the previous process run several times in parallel, with one subsequent time series to stats process, all packaged together as one CWL workflow, demonstrating the fan-in pattern. Let's dive into Eurodata Cube and open the dashboard for a specific user to navigate to his specific Jupyter Lab workspace hosted on EOxHub. This user has the EWPS processing solution already enabled, and we can see in his workspace that one process, the DLR single-step process, is already deployed, defined as an EO application package of type CWL command line tool. Let's check the output, and we can see that no process run has been performed yet. I will start this single-step process now for a specific region, something I can do via an API call in the background. While this process is running, let's deploy a second process in the meantime, the DLR workflow process, again via an API call in the background. Here you can see the process description, an EO application package of type CWL workflow, ready to be invoked. In the meantime, our first process finished, with all generated artifacts accessible in the user workspace, processing results, intermediate downloads, and usage statistics. We see much potential in leveraging CWL to describe EO processing workflows, and lots of more things to explore in future. But let's get started now. Thanks for watching.